Okay, so let's start our class for today. So today we will be looking at big data and we will be able to see where we can apply big data and which tools we can use. So I have this presentation here, which we are going to go through, explaining what big data is. So let's begin. So what is big data? So you can think of big data as huge amounts of data set that are hard to work with using the normal tools that you use at work. So for example, if you are using Excel, so you won't be able to work with such kind of data using Excel, because Excel I think has a limit of 1 million rows. So if you have a data set that has more than 1 million rows, so you can't use Excel. So big data is a collection of data that is in huge volumes, yet growing exponentially with time. So it is a data with so large sizes and complexity that none of traditional data management tools can store it or process it efficiently. So do you guys know the reason as to why we have SQL? So SQL is there to sort the problems we have when handling big data. And that's the reason you guys had a session on SQL. So let's proceed to the next slide. So what are some of the examples of big data? So I won't use what is in the slide, so I'll just mention some based on where we are. So for example, an example of big data is the Safaricom transactions. So every minute we have thousands of transactions going through. So how does Safaricom store all this data? I don't know, but there must be a way they are storing this data. We have also Twitter, which has numerous number of tweets coming in each and every minute. Yeah, so there are many ways in which we can define or we can find big data. So for example, the stock market has data coming in each and every seconds. So those are some of the examples of big data that we have. Then we have types of big data. So we have the structured, we have the unstructured, and we have the semi-structured. So structured data can be, for example, the Safaricom transactions. So for the structured data, you know what each and every column represents. So for example, for the Safaricom transactions, we might have the recipient, the sender, and the amount sent, and the time that the transaction was made. For unstructured data, this is data that has no structure. So for example, if you check an image, so an image has no structure, so it's just numbers. So you won't be able to define what that image is. Then semi-structured is dataset that is both structured and unstructured. So for example, a website XML file is okay, so our website XML file. So I know you don't know what that is, but our website XML file is an example of a semi-structured data. So I'll get to show you that. So I'll show you some examples. So structured data. So any data that can be stored, accessed, and reprocessed in the form of fixed format is termed as a structured data. So over the period of time, talent in computer science has achieved greater success in developing techniques for working with such kind of data and also deriving value out of it. So however, nowadays, we are foreseeing issues with the size of such data grows to a huge extent. So typically sizes, so we have megabytes of that data. So unstructured data, so any data with unknown form or the structure is classified as unstructured data. So in addition to the size being huge, unstructured data poses multiple challenges in terms of its pre-processing for deriving value out of it. So a typical example of unstructured data is a heterogeneous data source containing a combination of simple text files, images, and videos. So images and videos are the best examples to use as unstructured data. Because, for example, if you are working at Elon Musk company, which is Tesla, so if you are creating that model that they are using for self-driving cars, you would have to work with unstructured data, and this unstructured data is video recorded on the roads so that these cars can know how to define things that they are seeing in on the road. Okay. So nowadays, organizations have wealth of data available with them, but unfortunately, they don't know how to derive value out of it since this data is in its raw form or unstructured format. Then we have semi-structured. Semi-structured data can contain both the forms of data. So we can see semi-structured data as a structured in form, but it's actual not defined with a table, for example. So example of semi-structured data is a data represented in an XML file. So we can check an XML file example and see how it looks like. So this is an XML file. Let's open this image in a new tab. So if I open this image in a new tab, so I believe the majority of you won't be able to like see what is here. But for me, if I check, I can be able to like tell what kind of data I have in here. So for example, here I can see we have a text, welcome. And after the text welcome, we have introduction, editorial notes about the team, setup, configuration, scribers, so things like that. So quick start guide, keyboard shortcut, mouse shortcut. So you can see, not unless you've interacted with an XML file there before, you won't be able to like say, this is what I have inside this file. But basically that's an example of an unstructured data. No, semi-structured data, sorry for that. Okay, let's proceed. So what are the characteristics of big data? So we have volume. So you already know that big data is huge in size. So these should be terabytes or gigabytes of data. Then variety. So variety, it means that this data is in different forms. So for example, we've seen the images and all that. We have, so variety actually is not the difference, the different forms of big data that we have, but variety is big data keeps on changing each and every time. So the Safaricom transactions that are coming in this week might not be the same as the ones that we will have next week. Remember that next week people will be receiving their salaries, so we expect those numbers to rise. So that's what we mean by variety. Then velocity. Velocity means the time it takes for us to like generate this data. So for example, for social media data sets, these data sets are generated in large amounts every second. Then variability is the different data set that we have. So for example, videos, images, text, and all that. Yeah, so you can see here from this explanation. So volume, the name big data itself is related to the size, which is enormous. Then variety refers to the heterogeneous sources and the nature of data, both structured and unstructured. During earlier days, spreadsheets and databases were the only sources of data considered by most of the applications. So nowadays, data is in forms of emails, photos, videos, monitoring devices, PDF, audios, etc. Then velocity, the velocity refers to the speed of generation of data, so how fast data is generated and processed to meet the demands. Then variability refers to the inconsistency. So I confuse this. So variety and variability. So from my definition, we need to interchange. So variability refers to the inconsistency, which can be shown by the data at times. So that's hampering the process of being able to handle and manage the data effectively. Okay, so we have our summary here. So we've defined what big data is. We've defined some examples of big data. We've defined the types of big data and the characteristics. So what you should do is you guys can go and research more on maybe the advantages that we have on the availability of big data. Yeah, so that's all for the theory part. So let's go to the practical part. So let me upload this to our drive folder here. then you'll have access to the presentation. Okay, so the presentation is in. Okay, so when we talk of big data, so the tool that I'm going to use is PySpark. And you can only work with this tool on Colab mostly, because I believe when you try working with this library on your local machine, you'll have challenges because you are working with datasets that are big in size. So first of all, I'll have to locate this dataset, then share the link with you. Okay. Let me search for this file in my drive. Okay, so this is the file. So if we check the file information, so it was shared with me with someone else. So you can see the file is 2.34 gigabytes in size. So it will prove maybe not advantageous to download the file. Okay, but what I can do is I can copy this link and I can share with you. So I'll copy that link and I'll click on done. So let me share this in the chat section for now, but I'll share it with you later on while you will be working with the notebook. Or what I can do is I can add it here. So data link. That's the dataset link. Okay, so let's start the part for big data. So when working with big data, mostly we work with a library known as PySpark. So PySpark is a combination of SQL and Python. So this is the PySpark documentation website. Okay. And when working with PySpark, the first thing you need to do is you need to install the library. So you can click on get started and you can go to the installation part. So we will be using the PyPy installation method. So which means we should just run pip install PySpark. So that's what we have here. So I'll connect my notebook, then we will run the installation code here. Okay. Okay, so hope you can see my code. So this is the code to install PySpark. So you just run pip3 install, then PySpark. So let's run that, then we'll see what happens. So that installs PySpark. So it will take a minute or so to do the installation, then you'll be good to go. So after installing PySpark, what is the next thing we do? So here we follow the quick start part. So the quick start mentioned that first, after installing the PySpark library, we should initialize a PySpark session. So which is the entry point of PySpark. So this is the code that we use to instantiate our or initialize our PySpark session. So we will have from PySpark.sql import Spark session. Then after importing Spark session, we will specify a variable called Spark and say let Spark be equal to Spark session.builder.get or create. Then in here you can give your Spark session an name. Yeah. So this is what we have here. So we import from PySpark.sql import Spark session. Then we have Spark being equal to Spark session.builder.master. We specify our work environment. So our work environment should be local, then app name. So our app name is Jan intake. Then we get or create. So for example, if we had instantiated our application Jan intake, this method that we have over here will get the app, or if it's not there, it will create a new session for us. So we can run that. So you will be using this same code for initializing your Spark session. Okay, so that's what you will be having. So let me share the link to this notebook so that maybe if you are checking from your side, you can also see what I'm looking at. But I'll share these also with you later on after the class. Okay, the next thing we need to do is we need to load this data that is on my Google Drive. So first of all, what I'll do is I'll connect my Google Drive to Colab. Okay, so my Google Drive account has been connected. So here you will see, apart from sample data, we will have a folder called Drive, and that will be my Google Drive account where the data set is stored. So if I refresh, you can see we now have my Drive account here. So I can load in data from my Google Drive account. So let's proceed on. So already I know the name of the dataset is, and the dataset is stored inside this path. So it's zipped. So first of all, I'll have to unzip this dataset. So I'll run this to unzip the dataset. And inside that dataset, we have, I think it should be six files. So 6 different files, so which represent 6 different days from the 14th. Okay, so after doing that, how do you load CSV files from Spark? So Spark is somehow similar to pandas. So what you do is you type in spark.read.csv. So instead of typing in pd.read_csv, you type in spark.read.csv. Then you specify the file path for your CSV files. So remember here, so if we check our file path, we have a new folder. So this is the folder with the extracted CSV files. So here we have these 1, 2, 3, 4, 5, 6, 7. We have 7 CSV files that we want loaded. So what we do is we specify this path here. So if I click on that, if I click on these 3 buttons that we have here and click on copy path, you can see that's the path we have. So this is the path that I am passing in here. And what I'm doing here is I'm specifying star.csv, which means that I'll be loading all these 6, I think it's 7 files, all these 7 files, and I'll concatenate all those files. Okay, so that's what it means. Then header being equals to true means that our files, so these files that are over here, these CSV files, have headers. Okay, so we can run that. Then we can, so this will take time to load because we are loading 2.35 gigabytes of data. So yeah, so once it's loaded, we type in IDS_def.show. So remember here, this is the variable name we gave to our data frame that has been created by this import code. So we can type in IDS_def.show to visualize our data frame. So this is the Spark data frame, and this is how it looks like. So we have some few things here. So we have these columns, we have all those columns. Okay, and basically that's how you import data using Spark. Any questions? on the introductory to Spark part. So how you initialize Spark and how you load data to Spark. Any questions? Okay, so if we have no questions, then we can proceed on to the next part. And the next part is Spark SQL. And this is the part for data manipulation using Spark and SQL. So what I'll do is I'll go back to the documentation side. And here we will check the working with SQL part here. Okay, so when working with SQL on Spark, first of all, we have to create a temporary view. So remember when you were working with MySQL Workbench, you had tables and views. So what we have over here is a table, but to work with PySpark SQL, we have to create a temporary view. And that's the view that we will be running our SQL scripts on. So that's what we have here. So we type in IDS df, so which is our data frame name. Then we create or replace temporary view. Then we give it a name. So our temporary view will have the name IDS SQL. Okay, so that's our temporary view name. Okay, so after creating our temporary view name, we have to follow these syntax in querying our data. So first of all, we type in spark.sql. Then inside spark.sql, we type in our SQL script. So this is the normal SQL script that you are writing when working with MySQL. So that is Workbench. Then after that, we type in .show at the end to see the results of our query. So this is an example. So we have spark.sql, then we open brackets. Then in here, we type in our SQL script. So select star from IDS SQL, then limit 10. So that's a normal SQL script. We close the brackets, then we type in .show at the end to see the results of our script. So we haven't run this, create our temporary view. So we should run that, then we can come again and run this. So give me a minute, I get some water, then we can proceed. So I am back. So this is our SQL query sample, and this is our SQL query sample too. So I can run that. So select distinct destination port from IDS SQL. So these are just examples I'm showing you. So the main thing you should understand is the syntax part here. So how do you run your scripts? And I've already shown you the syntax and I've shown you the example. So basically that's how you do it. So you can get the maximum of a column, the minimum, and all that using Spark. So this is running, so you can see it's taking quite some time to run. So, and this is fast. So if we were using the normal Python to run this, then it will take even longer than we've seen it doing here. So yeah, that's it. So this is one for getting the average. This is one for getting distinct labels. This is one for getting the sum, having labels, something like that. This is, yeah. So these are some of the examples that we have. So this is like a bigger query example. So if you would like to like ignore this part here and go ahead and create a query that is long. So you can just create a variable and write in your query, and when you type in spark.sql, just type in the query variable in there and you should get your results. So any questions on this part for writing SQL queries? So this should take you back to your class on MySQL. So my main focus was on the syntax part because already you've learned MySQL, so I can't repeat that. Yeah. So the next thing is the, yes.
I think there is something I missed because I think I had some issues here. I didn't hear you, but maybe if you can go up on the 9.9.
Yeah.
Below the syntax, yes.
Yes.
And the variable that has been passed in. Okay, the information that has been provided is just selecting the amount of data that you wanted, right?
Yeah.
Right. Oh, I got it.
Yeah. So just selecting 10 rows from our dataset view. Okay. Then we have the Spark functions part. So the Spark functions part is not that much relevant because SQL covers all you need to do. So if you want to get the average, standard deviation, sum, and or if you want to group your data and all that, you can use a normal SQL codes. But there is a second way in which you can do that, and that is by using the PySpark SQL functions. So here you will type in import pyspark.sql.functions, okay? And if we type in something like f dot, so let's run this first. And then if we type in something dot f dot, we have a few things that we can do. So here you can see, if I go through the list, we have f dot union, tuple, value views, cast, absolute, echoes. So aggregate, approximate count distinct, approximate count distinct, array append, array. So we have some, so array join, array max, array min, array position. So we have some functions that we can run in here. But using the function, the PySpark functions at times is complicated. So you can get the covariance, population, but I guess you can do that using MySQL. So using functions at times might be complicated, but I'll show you how you can run functions. So first of all, you will be using your original data frame. So instead of creating a temporary SQL view, you will just use your original data frame. Then after typing in your original data frame, you will type in .select. Then after typing in .select, you will open your brackets, then type in F, then what you want to do with that specific column. So the F functions from PySpark only work with single columns. So you will be doing this for only single columns. So which at times is tiresome. So instead of doing this, just stick to SQL, which allows you to like type in the whole query at once and for all the columns that you want. So for example, if we want to get the variance for the population, we can type in f.var_pop, then we can type in flow duration, then we can type in .show. That will give us the variance. Yeah, so that's how we work with functions, okay? So for functions, it is as easy as that. So the next part is the machine learning part with PySpark. So how do you fit machine learning models for big data? So for big data, we can use so this is where the F function is important because you can't use the SQL here, but I believe there is a way in which you can use SQL here also to like format your data set. So first of all, we have this whole data set here. So if we type in IDS idf.show, let me zoom in again. If we type in IDS idf again.show, we have these columns of data that we have. So for us to fit a machine learning model, remember we mentioned that we need to have our values in numbers. So we need to only work with numeric data types. So what we do here is, first of all, we have to convert each and every data set that we have here to be numeric because we don't know what format they are in. So PySpark does not show us that. So for example, we can select, so we use the functions part that I've shown you here to select the columns that we want, and we cast them as float. So we will have f.call, we open that bracket, then .cast, then float. And we give it a name again, so float duration, so the same name that we were doing. And we do this for all the columns that we want. Then that will be, we store all these. So here we've selected 1, 2, 3, 4, 5. We've selected 5 columns and we have stored them in the data variable. So the label column will be our data column. Then there is something known as the vector assembler. So what is the vector assembler? So the vector assembler creates a vector of data with all the features that you have. So for example, this is part of PySpark. So here you can see it converts the features into a vector. So PySpark works with these more better as compared to like sklearn, where we have all the features in terms of our data frame. So here we instantiate our assembler after importing the vector assembler. Then we say, let our vector assembler be these. So we specify our input columns. So our input columns are these four, and the output column. So it will output only one column, and this single column will be a vector, and the single column name will be known as features. So after instantiating our vector assembler, what we do is we type in assembler.transform. So this is like saying, so remember in sklearn we had the maybe model.fit. So this is like saying model.fit, but here we say assembler.transform. So assembler.transform, then we transform our data set. Then we store it in data2. Okay, then if we come back up here, we can see our label column is a string and not numerical. So how do we solve that again? So what we do is we use something known as the string indexer that is in PySpark. So a label indexer that maps a string column to label to an ML column of label indices. So what it does is it will map those strings that you have into numbers. Okay. So what we do here is we import, so from pyspark.ml.feature, import string indexer. Then we instantiate our string indexer. And again, we are going to specify our input column and the output column name. So our input column is label, so this column that we have here, and our output column is label, so small l. So now we will have two columns of interest, so features and label of small l. Then after doing that, we do the indexer.fit. So what we've instantiated up here, then transform. So once we've fitted this to our data, we transform it again. So we store that as data 3. Then we can go ahead and fit our models. So for random forest, we can have from PySpark.ml.classification, import random forest classifier. Then this is how you split your data into training and tested. So it's different from what we were previously using, but you can basically use the same code we were using, so train test split. But here we specify a tuple. So this tuple will have our training data and our test data, and this will be equal to data3.random split. So we have random split. Then we specify what should be on our test data and what should be on our training data and what should be on our test data. So 70% will go into the training data and 30% will go into the test data. Then for our model fit, we will have our RF. So this we are instantiating the model. Then we have random forest classifier. Then the label column should be this column that we've created here. Then the features column should be this column that we've created up here. Then the number of trees is a hyperparameter. Then we have our model being equal to rf.fit. Then we can print out our model predictions. So let's run this and see how long it takes. So this is going to take some time to run. But as that is running, we can go through what I'll expect you guys to do is PySpark is quite large, but I've shown you maybe the basics parts. So what I'll expect you to do is if you want to learn more about PySpark, is you can go to the PySpark website and check the documentation. So it has everything you need to know. But I believe the majority of you won't be working with big data that much, because you see this course of ours was to give you just an introduction to big data and show you how you can work with big data. So mostly if you are working in organizations same as mine, so let me pause this first.
You can put it on the chat